Welcome to math, where every solution leads to a new problem. And welcome back to the channel. I'm your host, Noah Rodriguez, and today's topic is one of my favorite, actually, my favorite topic from calculus. We're going to be talking about derivatives, but more specifically today we're going to be diving into the power rule. Now, the power rule is very fun to do, very simple, sweet, straight to the point, everything. Now, in the power rule, let's say you have a function and you have a power, which in this case we can represent as a universal a, x, n. X would be your variable, n is your power, and a is whatever you multiply that variable by. Examples could be x to the 2, 3x to the 4, and 1/2, sorry, that looks like a plus sign, 1/2 x to the 3. Now, if you were to have derivatives, which we can represent as d over dx, or you can represent as f prime of x, how do we turn this ax to the n into a derivative power? Now, this is where the power rule comes in, and the power rule can be represented as the following function. N, right, we'll put this here in between parentheses so you know it's a multiplication, n, and then you multiply that times ax n minus 1. Now, with this power rule, what you basically did is that you took whatever your power was in the original function, and then you multiplied the ax by that, or rather you multiplied the a by that, which in this case would be n. Now, once you're done with that, you'll be left with your new number to multiply the variable by, and then the power will take minus 1. So let's put this into an example so I can explain it better. We're gonna work with each of these 3 examples. Now, for the first example, we're gonna work with x to the 2. Now, with x to the 2, if you want to find the derivative for it, you basically just take the power, like shown here, and then you multiply it by this. So we get 2x, right, to the 2. So you get 2x to the 2, since this is x, this is 1x. It's like an x or a 1 that is occult because it is not necessary to be shown. Now, you multiply the 2 by the 1, which gives you 2x, but we're not done here. This 2 requires the negative 1. So in this case, we just get 2x to the 1, which is also just 2x. Pretty simple, right? Let's do it with the other ones. Let's see how this works. We're going to go with 3x to the 4. Like earlier, you take the power and you multiply it by the a value, which in this case is 3. So you get 12x and then to the 4, but remember, we're not done. So here you go, minus 1. So you get 12x to the 3. Really, really, really simple. And once you start doing these at a rapid fire rate, it's very, very, very fun. Now, for the final example, we used a fraction just to show it can be done with anything. So we got 1/2 x to the power 3. Again, you take this and you multiply it by this. So 1/2 of 3, you could say 1.5, you can say 3 over 2. Since we already used fractions here, let's just go with 3 over 2, which is equal to 1.5. So we get 3 over 2x to the 3, but remember, once again, minus 1. Very important. You can never forget that. So then we go 3 to the 2, x, and then the 3 minus 1 just leaves you with 2. This right here is your derivative. Very, very, very simple. And one of the many, many, many rules to find derivatives, which is one of the most important things you'll need to know for your calculus class. Thank you so much for watching, and we'll see you in the next one. Goodbye.